I grew up spending summers at my grandparents' cabin in Gunnison County, on a patented mining claim above Tin Cup. After my grandmother's death, I inherited the property. While clearing drainage near the cabin one spring, I accidentally breached an old sealed mine at it, one that had been closed with a concrete block bulkhead by the state decades ago, before my grandparents bought the claim. What I found inside doesn't match any mining operation I can identify. The story is about what the mine contains and why it was sealed in a way that doesn't correspond to standard reclamation. I had been spending summers at my grandparents' place in Gunnison County since I was 6 years old. The cabin sat at 10,800 feet on a 20-acre patented mining claim above the ghost town of Tin Cup, at the head of a drainage that fed Willow Creek before it reached Taylor Park. My grandfather bought the claim in 1971 from the estate of a man named Lyle Kreider, who had worked it intermittently for decades without producing much of anything. The deed came with the cabin, a collapsed equipment shed, a Forest Service road easement, and a concrete sealed mine entrance that my grandfather was told had been closed by the state sometime in the early 1960s. My grandfather never showed much interest in the mine. He was a high school principal from Grand Junction who wanted a place above timberline where he could read and fish and watch the weather come over Cumberland Pass. My grandmother kept the cabin after he died in 2003. She kept it after her knees made the trail from the parking pullout difficult. She kept it even after the county sent a letter in 2019 suggesting the road to the upper claims might not be maintained past the following year. When she died in January 2024, she left the property to me. I should explain what I do for a living, because it matters. I'm a residential contractor in Salida. I build houses. I understand foundations, drainage, load-bearing walls, and what happens when water goes where it shouldn't. I mention this because what happened at the mine started as a drainage problem, the kind of thing I solve for clients every week, and became something I have no professional framework for. If you're someone who values careful, honest accounts of things that don't quite add up in the backcountry, this is the channel for that. Ashwarden Horror documents real investigations in real wilderness, told by people who were actually there. If that sounds like something worth following, consider subscribing. Let me get back to it. I drove up to the cabin the first week of June 2025 to assess winter damage and decide whether to keep the property or sell it. The road was passable, but ugly snowmelt had carved a channel down the east side that would need gravel and a culvert before fall. The cabin itself was in better shape than I expected. Tight roof, solid logs, no animal damage I could see. My grandmother had hired a local handyman to winterize it every October, and he'd done good work. The problem was below the cabin, on the downhill side where the old mine entrance sat. Continue to part 2. Let me write this properly now as a complete part 1. I had been spending summers at my grandparents' place in Gunnison County since I was 6 years old. The cabin sat at 10,800 feet on a 20-acre patented mining claim above Tin Cup, at the head of a drainage that fed Willow Creek before it reached Taylor Park. My grandfather bought the claim in 1971 from the estate of a man named Lyle Kreider, who had worked it intermittently for silver and lead without producing much of anything worth hauling down the mountain. The deed came with the cabin, a collapsed equipment shed, a Forest Service road easement, and a concrete sealed mine entrance that my grandfather was told had been closed by the state sometime in the early 1960s. My grandfather never showed much interest in the mine. He was a high school principal from Grand Junction who wanted a place above timberline where he could read and fish and watch weather come over Cumberland Pass. My grandmother kept the cabin after he died in 2003. She kept it even after her knees made the walk from the parking pullout difficult. She kept it even after the county sent a letter in 2019 suggesting the road to the upper claims might not be maintained past the following year. When she died in January 2024, she left the property to me. I should say what I do for a living, because it matters to this story. I'm a residential contractor based in Salida. I build houses. I understand foundations, drainage, load-bearing walls, and what happens when water goes where it shouldn't. I mention this because everything that happened at the mine started as a drainage problem, the kind of thing I solve for clients every week, and became something I have no professional framework for. If you're someone who appreciates careful, honest accounts of things that don't add up in the backcountry, things told by people who were actually there, this is the right channel. Ashwarden Horror documents real investigations in real wilderness. If that's something worth your time, I'd encourage you to subscribe. I drove up to the cabin the first week of June, 2025 to assess the winter damage and decide whether I wanted to keep the property or list it. The road from Tin Cup was passable but rough. Snowmelt had carved a channel along the east shoulder that would need gravel and a culvert before fall. And there were 2 downed aspens across the last switchback that I had to cut with a handsaw before I could get the truck through. The cabin itself was in better shape than I expected. Tight roof, solid logs, no animal intrusion. My grandmother had paid a handyman out of Gunnison to winterize it every October, and he'd done reliable work. The problem was 60 yards downhill from the cabin, on the south-facing slope where the old mine entrance sat. My grandfather had pointed it out to me once when I was maybe 11. It wasn't dramatic, just a flat concrete face set into the hillside, maybe 4 feet wide and 5 feet tall, with a rusted steel drain pipe protruding from the bottom center. The concrete was rough, poured in place against the rock rather than formed with any precision. He told me the state had sealed it before he ever bought the property, and that I should never try to mess with it. I didn't. It was just part of the landscape up there, like the collapsed shed or the tailings pile that had grown over with willows. You noticed it, then you stopped noticing it. What I saw when I walked down there the first week of June was different. The snowmelt that year had been heavy and late. The drainage that ran along the base of the slope, normally a trickle by June, was running hard enough that it had undercut the bank on the uphill side of the mine entrance by about 18 inches. The soil was loose glacial till up there, not bedrock, and the water had done real work. The concrete bulkhead was still intact, but the ground beneath its left side had eroded. I could see a gap between the bottom of the concrete and the exposed rock underneath, maybe 8 inches tall, 1.5 feet wide. Not large, but enough that water was flowing into it from the drainage and disappearing under the seal. If this had been a client's foundation, I would have told them they had a serious water management issue and quoted them for regrading and a French drain. But this wasn't a foundation. It was a 60-year-old mine closure on a mountainside at nearly 11,000 feet. And the water wasn't pooling. It was going in and not coming back out. That bothered me for practical reasons, before it bothered me for any other reasons. Water flowing into a sealed mine with no visible exit means one of 2 things. Either the mine has internal drainage that carries it deeper underground, or the water is accumulating behind the seal and building hydrostatic pressure against the concrete. The first scenario is fine. The second one isn't, because eventually the pressure wins, and you get a blowout, concrete, water, mud, and whatever else is in there coming downhill at once. My cabin sat 60 yards uphill, but the equipment shed's old foundation was only about 30 feet from the entrance, and the road switchback was directly below. I spent that first afternoon just looking at it. I measured the gap with a tape. I watched the water. I timed the flow rate with a bottle, roughly 2 gallons a minute, so entering the gap, nothing visible exiting anywhere on the slope below. I walked the entire perimeter of the tailings area and the slope below the entrance, looking for a spring or a seep that might indicate the water was passing through the mine and exiting somewhere downhill. I didn't find one. I ate dinner at the cabin that evening and thought about what I was going to do. The responsible thing was to call the Colorado Division of Reclamation, Mining and Safety. They're the state agency that manages abandoned mine closures and report the erosion. But I'd dealt with state agencies on construction projects before, and I knew what the timeline would look like. Weeks to get someone assigned. A site visit that might not happen until late summer. An assessment report. A NEPA review if any modification to the closure was needed. By the time anyone with authority showed up, the entire spring runoff could have compromised the seal. I also had a more immediate question that I couldn't resolve by phone. The concrete bulkhead had no markings on it. No agency insignia, no date stamp, no closure identification number. Every mine closure I've ever seen documented by DRMS, and I've seen a few around Chaffeo and Gunnison counties, has some form of identification. A stamped plate, a painted number, a reference tag. This one had nothing, just plain concrete against rock. The next morning, I drove down to Tin Cup, which in June consists of about a dozen summer residents and a small store that may or may not be open, depending on whether the owner has made it up from Gunnison yet. The store was open. The woman running it that morning was named Bev, and she'd been spending summers in Tin Cup since the 1980s. I asked her if she knew anything about the mines on the upper claims above town specifically, whether she remembered anyone from the state coming up to do closure work. She said the state had done a round of closures in the area in the late 90s, mostly on the east side of the valley. Concrete blocks, steel grates, some polyurethane foam on the smaller openings. But she said she didn't think they'd done anything on my grandfather's claim. She remembered my grandfather, actually called him the reading man, because she'd see him on the porch with a book every time she drove past. She said he once told her the mine on his property had been sealed before Colorado even had a reclamation program. That gave me a timeline to work with. Colorado's inactive mine reclamation program started in 1980. If my grandfather was told the mine was sealed before that program existed, the closure predated any formal state process, which might explain the lack of identification markings. It could have been done by the previous owner, by the county, by the Forest Service, or by some earlier state initiative. Or it could have been done privately, by Kreider himself or someone he hired for reasons I didn't know. I drove back up to the cabin and spent the rest of the day working on the drainage issue in the way I knew how, which is to say, I worked on the parts I could control. I diverted the main flow of the drainage channel away from the mine entrance using a shallow trench lined with rocks I pulled from the tailings pile. It wasn't elegant, but it reduced the volume of water reaching the gap from about 2 gallons a minute to a trickle. I figured if I could buy a week or two of reduced flow, the seasonal decline in snowmelt would do the rest, and I could report the erosion damage to DRMS without the urgency of an active water intrusion. That evening, sitting on the porch with a beer, I heard something I hadn't heard before at the cabin. Or rather, I felt something I hadn't felt before, and then heard something that matched it. What I felt was a faint pulsing in the air. Not wind, not a gust. A rhythmic change in pressure, very subtle, like standing near a large ventilation system that cycles on and off. It came and went over the course of maybe 10 seconds, 3 or 4 pulses, and then stopped. A few minutes later, it happened again. Same rhythm, same duration. What I heard, faintly, was a low sound from downhill. Not mechanical, more like a deep exhalation, a breath being let out and through a narrow opening. It came from the direction of the mine entrance. I'd read enough about mine ventilation to know that abandoned mines can produce airflow. It's a well-documented phenomenon. Temperature differentials between the underground air and the surface air create a pressure gradient. and the mine breathes air moves in or out through any available opening, depending on the season and time of day. In summer, when the surface air is warm and the underground air is cold, you'll often feel cool air flowing out of a mine entrance in the evening as the surface temperature drops and the pressure differential shifts. The gap under the concrete seal was an available opening. What I was hearing was probably just the mine breathing through that gap. It was exactly the kind of thing that has a straightforward physical explanation. But the rhythm bothered me. Natural mine ventilation doesn't pulse. It's a steady flow governed by slow-changing temperature gradients. What I was hearing had a cadence to it, on, off, that didn't match any airflow pattern I could attribute to simple thermodynamics. I walked down to the mine entrance with a headlamp. It was about 9:30, still not fully dark at that elevation in early June. I knelt beside the gap and held my hand in front of it. Cold air was flowing out. Noticeably cold. I'd estimate the mine air was in the low 40s, maybe high 30s. The surface temperature was probably around 50, and the flow was pulsing, exactly as I'd felt from the porch. A push of air lasting 2 or 3 seconds, a pause of about the same, then another push. It wasn't strong. If I hadn't been kneeling right at the opening, I wouldn't have felt it. I put my ear close to the gap and listened. During each pulse, there was that low sound, a soft, resonant exhalation. Between pulses, silence, no dripping, no water sound at all, which struck me because I'd watched 2 gallons a minute enter this gap for the better part of a day. I went back to the cabin. I didn't sleep particularly well, but not because I was frightened. I was doing the thing I do with construction problems, running scenarios. The pulsing airflow could be explained by a restriction somewhere inside the mine, a partial collapse, a narrow passage that was creating a pressure relief cycle. Air builds up behind the restriction, exceeds the threshold, pushes through, equalizes, builds again. I've seen water systems do this with trapped air pockets. It's called water hammer in plumbing. The principle could apply to air in a confined, underground space. The next morning, I did something I'd been avoiding. I got on my hands and knees with a headlamp and looked into the gap. The erosion had exposed about 18 inches of clearance between the bottom of the concrete and the rock beneath it. Beyond the concrete, I could see maybe 4 feet into the adit before the light was absorbed by darkness. The floor of the tunnel was wet standing water, maybe an inch or 2 deep. The walls were rough-cut rock, consistent with a hand-dug adit from the late 1800s. Nothing unusual, nothing remarkable, except the ceiling. About 3 feet past the concrete seal, where the headlamp beam hit the ceiling of the adit. Something was wrong with the rock. The surface wasn't rough-cut like the walls. It was smooth and not polished smooth, more like the way limestone looks in a cave where water has been flowing over it for a long time. But this wasn't limestone. The country rock up there is a mix of Paleozoic sedimentary formations and tertiary intrusives, mostly granodiorite and quartz monzonite in the immediate area of the mining claims. That kind of rock doesn't develop smooth, flowing surfaces from water contact. Not in any time frame that makes sense for a mine that's been sealed for 60 years. The smooth area covered maybe a 3-foot section of the ceiling that I could see. Beyond that, the darkness was complete. I couldn't tell if the smoothing continued deeper into the adit or if it was localized to that area near the entrance. I pulled back from the gap and sat in the dirt for a while. Here's where I need to be honest about what I did next and why. I'm a contractor. I work with concrete every week. I looked at that bulkhead and I could see that it was failing. The erosion had undermined the footing on the left side. The concrete itself had no rebar. I could see the edge where the gap had opened, and it was plain, unreinforced concrete. Whoever poured this hadn't built it to modern standards, and 60 years of freeze-thaw cycles at 10,800 feet had done their work. There were hairline cracks running across the face that I hadn't noticed before. The seal was going to fail eventually. The spring runoff had just accelerated the timeline. What I told myself was that I needed to enlarge the gap slightly to assess the water situation inside, to determine if there was pooling behind the seal that posed a blowout risk. What I actually did was use a pry bar and a masonry chisel to remove a section of the deteriorated concrete along the bottom left edge of the bulkhead. It took about 2 hours. The concrete came away in chunks. It was poorly mixed, too much aggregate, not enough cement, and the freeze-thaw damage had weakened it to the point where I wasn't so much breaking it as disassembling it. When I was done, I had an opening roughly 2.5 feet wide and 2 feet tall at the base of the original mine entrance. Enough to crawl through on my belly. I want to be clear about my legal position here. This mine entrance is on my property. The patented claim gives me surface and mineral rights. I wasn't trespassing, and I wasn't vandalizing a state closure, or at least I don't think I was. The closure predated the state program, had no agency identification, and may have been a private action by the previous owner. I've since learned that the legal question of who owns an unmarked, undocumented mine closure on patented private land is genuinely complicated. But at the time, I was thinking about hydrostatic pressure and property damage, not legal nuance. I did not crawl in immediately. I'm not reckless. I drove down to the store in Tin Cup, bought a cheap lighter, drove back up, and held it at the opening. The flame pulled steadily inward. That told me the mine was drawing air in. At that moment, the thermal gradient had reversed with the midday warmth. More importantly, the flame burned clean and steady. No guttering, no color change. If the mine had dangerous concentrations of carbon dioxide or methane or hydrogen sulfide, the flame would have behaved differently. It's not a perfect test, but it's the one miners used for 200 years, and I trusted it more than my courage. I also rigged a rope to a boulder uphill of the entrance, ran it through a carabiner on my belt, and told myself that if I felt dizzy, short of breath, or disoriented at any point, I would back out immediately and drive straight to Gunnison. I had cell service at the cabin, barely, 1 bar, and I sent a text to my business partner in Salida that said, "At grandmother's cabin, going into the mine on the property to check water damage. If you don't hear from me by 6 p.m., call Gunnison County Search and Rescue." He texted back a thumbs-up emoji and the words, "Don't be stupid." I appreciated the advice even if I was already ignoring it. I crawled in at about 1 in the afternoon on June 8, 2025. The first thing I registered was the temperature. The surface air was around 65. Inside the mine, 5 feet past the seal, it dropped to what felt like the mid-30s. My breath was immediately visible in the headlamp beam. The second thing was the smell. Not sulfur, not rot, not standing water, which was itself surprising, given that water had been flowing in for weeks. What I smelled was mineral. Clean, cold, mineral air with a faint sweetness to it, like wet calcium carbonate, like a healthy cave. The adit was roughly 5 feet wide and maybe 5.5 feet tall past the entrance. I could crouch walk once I was through the gap. The floor was wet but not flooded, a thin film of water running along a groove that looked like it had been carved deliberately along the left side of the tunnel, a drainage channel. The old miners had cut it to keep the working face dry. Water from the spring runoff was following that channel inward and deeper, which explained why it wasn't pooling behind the seal. The mine had its own drainage, and it was working. That answered my water management question. There was no blowout risk. The mine was self-draining. I could have turned around right there, sealed the opening back up with some quick-set concrete from the hardware store in Buena Vista, and reported the erosion to DRMS at my convenience. Instead, I looked up at the ceiling. The smooth section I'd seen from outside extended further than I'd thought. It began about 2 feet past the concrete seal and continued for at least 20 feet into the tunnel, as far as my headlamp could reach from a crouching position. The walls were rough, tool-marked rock. The floor was rough, but the ceiling was smooth and gently contoured, with shallow, curving ridges that ran lengthwise along the tunnel. They looked organic. The best comparison I can make is to the inside of a throat. Not an animal throat, I mean the shape. The way a cylindrical passage narrows and widens in smooth, rhythmic undulations rather than angular facets. I touched it. The rock was cold and slightly damp, and it was hard, definitely stone. But the surface texture was unlike anything I'd encountered in construction or in any mine I'd seen. And I've been in a few around Chaffee County, the tourist-accessible ones. This was not tool-worked. It was not water-eroded, at least not by any process I recognized. It was smooth in the way that something is smooth when it's been shaped deliberately by something patient. I moved further in. The tunnel curved gently to the left, following what I assumed was the orientation of the ore vein. The smoothing continued along the ceiling and began to extend down the upper portions of the walls. The lower walls and floor remained rough. It was as if the upper 2/3 of the tunnel cross-section had been reworked by a different process than the one that created the lower third. At about 40 feet in, I found the water. The drainage channel along the floor converged with a natural crack in the rock, a fissure, maybe 2 inches wide, running diagonally across the floor and down into the bedrock. The water was flowing into that fissure and disappearing. I could hear it running below for a few seconds after it dropped through a faint, hollow sound that suggested open space beneath. The mine had intersected a natural fracture system, and the water was draining into it. From a construction standpoint, this was actually good news. Natural subsurface drainage is better than anything I could engineer. But the fissure wasn't what stopped me. Past the fissure, about 50 feet from the entrance, the tunnel opened into a wider chamber. The ceiling rose to maybe 8 feet. And in that chamber, the smoothing of the rock was complete. Ceiling, walls, floors, every surface had been worked to the same flowing, organic contour. The room was roughly oval, maybe 12 feet across and 15 feet long. There were no tool marks anywhere. No drill holes, no blast scarring, no chisel lines. The surfaces curved into each other the way the inside of a seashell does, continuous, uninterrupted, mathematical. And the air was moving. I could feel it on my face and the backs of my hands. A slow, rhythmic pulsing, the same pattern I'd felt from the porch the night before. In, hold, out, hold, in, hold, out, hold. Inside the chamber, the pulses were stronger, and I could feel the direction change. The air moved inward from the tunnel behind me during one phase, then reversed and pushed back toward the entrance during the next phase. The cycle took about 6 seconds. I stood in the middle of that chamber for maybe 5 minutes, feeling the air pulse around me, and I tried to think like a contractor. I tried to think about thermal gradients and pressure differentials and barometric effects. I tried to think about natural ventilation in mines with multiple openings, where a chimney effect could create airflow as warm surface air enters one opening and pulls cold underground air out another. But this mine, as far as I knew, had one opening. the sealed entrance I'd just crawled through. There was no second opening to create a chimney effect. And even if there were a hidden vent shaft somewhere above, which is possible in a mine, a chimney effect produces steady airflow, not rhythmic pulses. I was standing inside something that was breathing. I went back to the entrance. I crawled out into the afternoon sunlight. I sat on the tailings pile and drank most of a water bottle without stopping. Then I drove down to Tin Cup and sat in my truck outside the store for about 20 minutes, trying to decide what to do. What I decided was to go back the next day with better equipment and a more systematic approach. I'm a contractor. When I don't understand a problem, I measure it. I document it. I try to establish parameters. That's the only way I know how to respond to something I can't explain. I drove to Buena Vista that evening and bought a digital thermometer with a remote probe, a humidity meter, 100 feet of surveyor's tape, a box of sidewalk chalk, and a clipboard with graph paper. I also bought a carbon monoxide detector, the plug-in kind for residential use, and rigged it with a battery pack so it would work underground. The CO detector was pure safety. Everything else was for data. The following morning, June 9th, I went back in. I placed the thermometer probe at the entrance gap, the midpoint of the tunnel, and inside the chamber, recording temperatures at each location. Entrance gap, 41 degrees. Tunnel midpoint, 38 degrees. Chamber, 36 degrees. A 3-degree gradient over 50 feet. Nothing remarkable for a mine, but the temperatures were colder than I'd expect for June, even at that elevation. The rock mass at 10,800 feet should stabilize around 40 to 44 degrees based on the mean annual surface temperature. 36 was low. I timed the breathing cycle with my phone's stopwatch. The pulses were remarkably consistent. Inhalation phase, 2.8 to 3.1 seconds. Pause, 0.4 to 0.6 seconds. Exhalation phase, 2.9 to 3.2 seconds. Pause, 0.5 to 0.7 seconds. Total cycle, roughly 6.5 seconds. I timed 30 consecutive cycles, and the variance was less than half a second. I also measured the chamber more carefully. The oval's shape was not perfectly symmetrical. The longer axis ran roughly northeast to southwest, which didn't correspond to the orientation of the tunnel I'd entered through. The tunnel entered the chamber from the southeast. That meant the chamber was oriented at about a 40-degree angle to the tunnel. In mining terms, that makes no sense. You follow the vein. You don't blast out a chamber at an oblique angle to your working tunnel unless there's an intersecting vein or some geological reason to change direction. I couldn't see any evidence of a vein intersection. The rock in the chamber was uniform. The walls of the chamber had one other feature I need to describe. At roughly shoulder height, about 5 feet from the floor, there was a horizontal line where the character of the smoothing changed. Below the line, the rock was smooth but relatively flat, like the walls of the tunnel. Above the line, the smoothing took on a more pronounced curvature, as if the upper portion of the chamber had been shaped more aggressively or by a different process than the lower portion. The transition wasn't sharp. It was gradual, like a tide line. But it was visible, and it was consistent around the entire perimeter of the chamber. I chalked the line on the east wall so I could measure its height when I came back. Then I crawled out, made notes, and ate lunch at the cabin while staring at the numbers on my clipboard. Nothing I'd measured was impossible. Underground chambers with unusual shapes exist in mines that intersected natural cavities. Smooth rock surfaces develop in limestone caves over geological time. Airflow patterns in complex underground systems can produce effects that seem rhythmic over short observation periods. But this wasn't limestone. The rock was granodiorite hard, crystalline igneous rock that doesn't dissolve in water and doesn't develop smooth surfaces through any chemical weathering process I'm aware of. And the airflow pattern wasn't quasi-rhythmic, it was rhythmic. 30 consecutive cycles with less than half a second of variance is not turbulent airflow finding a temporary pattern. That's a system in equilibrium. I went back in that afternoon with the surveyor's tape and measured the chamber more precisely. What I found added another question I couldn't answer. The chamber was not static. Or rather, the chalk line I'd drawn on the east wall that morning, the one marking the transition in surface character at shoulder height, was no longer at shoulder height. It was about 2 inches above where I'd marked it. I know this because the chalk mark was still there, and the transition line was now visibly above it. I remeasured. The chalk mark was at 61 inches from the floor. The transition line was at 63 inches. I stared at this for a long time. Then I checked the other walls. I hadn't chalked them, so I had no reference marks, but I measured the transition height in 4 places around the chamber. 62 inches, 63 inches, 63 inches, 64 inches on the north wall. 2 inches of change in approximately 4 hours, in a solid rock chamber. I left the mine. I did not go back in that day. That night, I sat on the porch with the clipboard in my lap and the thermometer data and cycle time spread out in front of me. And I tried to build an explanation that accounted for everything I'd observed. The smooth surfaces could be geological. Unusual, yes, but not impossible. There are metamorphic processes that can produce foliated, smooth rock faces under the right conditions of heat and pressure, and the Sawatch Range has a complex, intrusive history. I wasn't a geologist. Maybe what I was looking at had a name I didn't know. The airflow could be mechanical in some sense I hadn't identified. Maybe the mine connected to a deeper natural cave system through the fissure in the floor. And the cave system had multiple surface openings that I couldn't see from my property. A large enough underground volume connected to multiple vents at different elevations could produce surprisingly regular airflow oscillations. Helmholtz resonates the same principle that makes a bottle hum when you blow across the top. I'd read about it in the context of cave acoustics. A large underground chamber with a narrow opening can oscillate at a natural frequency when driven by small external pressure changes. The period would depend on the volume of the chamber and the dimensions of the opening. 6.5 seconds wasn't unreasonable for a moderately sized natural cavity. The transition line was harder to explain. 2 inches of apparent movement in 4 hours. I kept coming back to 2 possibilities. The first was measurement error, maybe the chalk line had smudged, or I'd measured from a slightly different point on the irregular floor. Or the headlamp angle had created a visual distortion that shifted where the transition appeared to be. The second possibility was moisture. The smooth rock above the line was slightly wetter than the rock below it. And it was possible that the boundary between wet and dry was migrating as the airflow pattern changed the humidity distribution inside the chamber. What I'd been measuring might not be a change in the rock itself, but a change in surface moisture that made the smoothing more or less visible. I liked the moisture explanation. It was testable, it was physically plausible, and it didn't require me to believe that solid rock was rearranging itself over the course of an afternoon. I decided to go back the next morning with more chalk marks, more precise measurement techniques, and the humidity meter I hadn't yet deployed. June 10th. 3rd day inside the mine. I placed fresh chalk reference marks at the transition line on all 4 quadrants of the chamber wall, north, south, east, west, measuring carefully from the floor at each point. I also placed marks at 3 fixed heights, 48 inches, 60 inches, and 72 inches. so I'd have multiple reference points that were independent of the transition line itself. I pressed a piece of duct tape over each chalk mark to protect it from moisture. I placed the humidity meter at the center of the chamber, 3 feet off the floor, on a small tripod I'd improvised from stacked rocks and a piece of scrap lumber from the equipment shed. Then I left. I sealed the entrance gap with a tarp weighted down by rocks not airtight, but enough to keep animals out and reduce the direct exchange of air with the surface. I wanted to let the chamber reach whatever its equilibrium state was without me in it, breathing and radiating body heat and generally disrupting the environment. I went up to the cabin and spent the day doing actual property maintenance. Replaced some chinking between the logs on the north wall, tightened the stovepipe, cleared pack rat debris from under the porch. Normal work, the kind of work I understand. At 4 in the afternoon, I went back down and removed the tarp. The first thing I noticed was the air. Not the pulsing that was still there, same rhythm, same cadence, undisturbed by 6 hours of minimal ventilation exchange. What I noticed was the temperature. Even before I crawled in, the air flowing out of the gap felt colder than it had the previous 2 days. I checked the thermometer probe I'd left at the entrance. It read 34 degrees. The day before, the same probe at the same location had read 41. A 7-degree drop in the entrance temperature over 24 hours. While the surface temperature had actually increased, it was a warm, clear day. Probably 70 on the slope by afternoon. I crawled in and crouched, walked to the chamber. The air inside was cold enough that I wished I'd brought a heavier jacket. The humidity meter read 94%, which was high but not unusual for an underground space with active water intrusion. I checked the chalk marks. The transition line had moved again. On the east wall, where I'd measured 63 inches the previous afternoon, it was now at 66 inches. On the north wall, it had gone from 64 to 67. South wall, 62 to 65. West wall, 63 to 66. 3 inches of upward migration in approximately 20 hours. Consistent across all 4 measurement points. The duct tape over the original chalk marks was undisturbed. The marks themselves were still clean and sharp beneath the tape. The fixed reference marks at 48, 60, and 72 inches were exactly where I'd placed them, confirming that I was measuring from the same points. The moisture explanation was still technically alive. I checked the rock surface above and below the transition line by touch. Above, cold, faintly damp. Below, cold, dry, consistent with a rising moisture front that was making the upper smoothing more visible. But I'd reduced the ventilation exchange with the tarp, which should have stabilized or even reduced the moisture migration, not increased it. And the rate was too uniform. 3 inches across 4 measurement points, spanning the full perimeter of an irregularly shaped oval chamber. Moisture doesn't migrate that evenly through crystalline rock. I sat on the floor of the chamber with my back against the wall and felt the air pulse around me while I tried to think of what to do next. The breathing was easier to adapt to than I expected. After 3 days of exposure, it had become almost background, like living near a highway, where you stop hearing the traffic until someone points it out. Sitting still in the chamber, I could feel each cycle as a faint pressure on my eardrums and a barely perceptible movement of air across my face. In, hold, out, hold. It was regular enough to set a watch by. I timed another 20 cycles, average 6.48 seconds. The day before, the average had been 6.52 seconds, functionally identical. I don't know how long I sat there. Maybe 20 minutes, maybe longer. At some point, I realized I was breathing in sync with the chamber, not deliberately. I hadn't decided to do it. My respiratory rate had simply adjusted, the way it does when you're sitting next to someone whose breathing you can hear. I noticed it and immediately changed my rhythm. Took a couple of deliberate, fast breaths. My chest felt tight for a moment, the way it does when you interrupt a yawn. Then it passed. I decided to explore further. Beyond the chamber, the tunnel continued, or rather, a passage continued. I say it that way because the geometry past the chamber didn't look like mining. There were no drill holes, no blasting patterns, no mucking tracks. The passage narrowed to about 3 feet wide and maybe 5 feet tall, and it curved to the right, descending at a grade of maybe 10 or 12 degrees. The surfaces were entirely smooth. The same organic, flowing contours that characterized the chamber extended into this passage, and as far as I could see in the headlamp beam, continued without interruption. The passage felt older than the mine. I don't know how else to describe it. The adit and the first 40 feet of tunnel were clearly human-made. You could see the drill and blast pattern, the tool marks, the squared-off geometry that miners impose on rock. The chamber was ambiguous. It could have been a natural cavity that the miners broke into and then enlarged, though the smoothing obscured whatever original geometry it might have had. But the passage beyond the chamber had no human signature at all. It was shaped, clearly shaped, but not by tools I recognized. I followed it for about 60 feet, counting paces. The descent continued, and the air grew colder. The breathing rhythm remained perfectly consistent, though the amplitude of each pulse, the amount of air moving past me increased as the passage narrowed. Venturi effect. Same volume of air through a smaller cross-section means higher velocity, consistent with a single driving mechanism at some depth, pushing air through the entire system. At 60 paces, the passage opened slightly, and I found water again. Not a trickle this time. A pool. It covered the full width of the passage floor and extended ahead of me into the darkness beyond my headlamp range. The surface of the water was moving, not flowing in one direction, but oscillating, pulsing, rising about 1/4 inch, falling 1/4 inch, in perfect synchrony with the air cycle. When the air pushed outward toward the entrance, the water level dropped slightly. When the air reversed and pulled inward, the water rose. The water was acting as a piston indicator. Whatever was driving the air cycle was also displacing water. That meant the driving mechanism was below the water level, deeper in the system, and it was volumetric, physically pushing air and water in alternating phases. I knelt at the edge of the pool and tested the water with my hand. It was cold, colder than the air. Cold enough that my fingers ached within a few seconds. I pulled my hand out and looked at it in the headlamp light. My fingers were red, which was normal. What wasn't normal was a faint, slightly iridescent residue on my skin, like a very thin film of oil, but without the slippery feel of oil. It dried within a few seconds and left a barely visible sheen. I smelled my hand. The same mineral sweetness I'd noticed on my first entry, but stronger, almost floral. Not a chemical smell, not sulfur or petroleum, something I had no reference for. I did not go further. The pool was my stopping point. I didn't know the depth, I didn't have waders, and crawling through an unknown underground passage is already well past the limit of reasonable risk. Adding cold water of unknown depth to the equation was where my self-preservation finally outweighed my curiosity. I made my way back through the passage, through the chamber, through the tunnel, and out the entrance. It was early evening. The sun was behind Cumberland Pass, and the drainage was in shadow. I sat on the tailings pile and wrote down everything I could remember while it was fresh. That night, I called a friend of mine named Dale Everett. Dale is a civil engineer in Buena Vista who does occasional consulting work for the county on road and bridge projects. He's not a mining engineer and he's not a geologist, but he understands rock mechanics and underground hydrology better than I do, and I trusted him to tell me if I was losing perspective. I described what I'd found without editorializing. The smooth surfaces, the breathing cycle, the migrating transition line, the water pool with the oscillating surface, the iridescent residue. I gave him the numbers, temperatures, cycle times, transition measurements. Dale listened to the whole thing and then asked me 3 questions. First, was I sure the rock in the smooth areas was the same lithology as the rough-cut mine walls? Or could the smooth areas be a different rock type, a dike, or an inclusion that responded to weathering differently? I told him I wasn't sure. I'm not a geologist. The color and grain looked similar, but I couldn't say definitively. Second, was there any chance the mine connected to a known cave system? There are karst features in parts of the Sawatch, though they're not common in the granodiorite. I told him I didn't know of any mapped cave systems in the immediate area, but I hadn't researched it. Third, was I willing to let him come up and look at it? I said yes. We agreed on the following Saturday, June 14th. I spent the intervening days doing something I probably should have done at the beginning. I went to the Gunnison County Clerk's office and pulled the property records for my grandfather's claim. The deed transfer from the Kreider estate in 1971 was straightforward. But I also found the original patent, filed in 1897, by a man named Thomas Honeycutt. The claim was called the Marguerite Lode. The patent documentation included a basic description of the workings as of the filing date. A single adit driven approximately 110 feet into the hillside on a bearing of south 35 degrees west, following a narrow vein of galena and sphalerite in granodiorite host rock. No mention of a chamber, no mention of unusual geological features, no mention of intersecting a natural cavity. 110 feet. I'd gone roughly 50 feet to the chamber, and then another 60 to the water pool. That put me at the approximate limit of the original workings. Everything I'd seen past the chamber was either a later extension of the mine, which seemed unlikely given the absence of any tool marks, or something the mine had broken into that wasn't part of the original excavation. I also looked for any record of the mine closure. Nothing in the county records. Nothing in the DRMS database, which I accessed through their online portal. The Marguerite Lode had no closure record, no inspection record, no reclamation record of any kind. As far as the state of Colorado was concerned, the mine entrance didn't exist, which meant the concrete bulkhead was private work. Someone Kreider probably had sealed that entrance on his own, with his own concrete, without telling anyone. And he'd done it before selling the claim to my grandfather. I sat with that for a while. A man who'd worked a mining claim for decades seals the entrance with concrete and then sells the property without mentioning why. My grandfather, a man who had no interest in mining, buys it and spends 30 years sitting on the porch reading books 50 yards from a sealed hole in the ground that the state doesn't know exists. Saturday morning, Dale drove up from Buena Vista in his truck with a hard hat, a Brunton compass, a rock hammer, a handheld anemometer, and a waterproof case full of sample bags. He also brought a pulse oximeter, which he clipped to my finger before we went anywhere. 98%. He told me he'd check it again when we came out, and that if it was below 94, we were done and I was going to the ER. We crawled in together. Dale is a careful man. He moved slowly, stopped often, looked at everything. He didn't say much for the first 40 feet. He ran his hand along the walls, tapped with the rock hammer, checked the compass bearing against the patent description. At the point where the rough-cut tunnel transitioned to the smooth surfaces, he stopped and spent about 10 minutes examining the rock. His first comment was that the smoothing wasn't metamorphic. He could still see the original grain structure of the granodiorite through the smooth surface feldspar phenocrysts, biotite, quartz, and they were undistorted. Metamorphic smoothing would have recrystallized or flattened the grain structure. Whatever had smoothed this rock had done it mechanically by abrasion or dissolution rather than by heat and pressure. His second comment was that dissolution of granodiorite requires either hydrofluoric acid or extremely long exposure to mildly acidic water. We're talking geological time, tens of thousands of years at minimum. The mine was less than 130 years old. Even if acidic groundwater had been flowing through the tunnel continuously since 1897, it shouldn't have produced this degree of smoothing. Unless, he said, the smooth surfaces predate the mine. That was the possibility I'd been avoiding. That the miners had broken into a pre-existing void that was already smooth when they found it. A natural feature of unknown age that the mine at it had intersected by chance. In the chamber, Dale spent a long time looking at the transition line. It had continued to migrate upwards since my last measurement. My chalk marks were now about 5 inches below the visible transition. Dale measured independently and got the same numbers I did. He didn't offer an explanation. He just wrote it down. He held the anemometer at the center of the chamber during several breathing cycles. Peak airflow velocity, 0.8 meters per second during the outward pulse, 0.6 meters per second during the inward pulse. Not strong, but measurable and consistent. He noted the asymmetry. The outward pulse was stronger than the inward pulse. He didn't comment on it at the time, but he told me later that asymmetric airflow in a single opening system is unusual. In a simple Helmholtz resonance model, the inflow and outflow should be roughly equal. We went down the passage to the water pool together. Dale knelt at the edge and watched the surface oscillate for about 2 minutes without speaking. Then he took a water sample in one of his bags. He dipped his fingers in, examined the iridescent residue, smelled it, and put a second sample in a separate bag. "This isn't mine drainage," he said. "There's no iron staining, no sulfide smell. The pH is probably close to neutral." He looked at me and asked how far past the pool the passage continued. I told him I didn't know. We both looked at the passage extending into the darkness beyond the water. The smooth walls curved downward and out of sight. The water's surface pulsed gently under our headlamp beams. Neither of us suggested going further. On the way out, Dale stopped in the chamber one more time. He stood still, feet apart, arms at his sides, eyes closed. I watched him. After maybe 30 seconds, he opened his eyes. "My breathing synced," he said. "I wasn't trying to do it. It just happened." I told him the same thing had happened to me. He frowned. "That's probably just a psychoacoustic response. You feel the rhythm, your autonomic system matches it. People's heart rates synchronize with rhythmic environmental stimuli. There's research on that." I agreed. It probably was that. But we both stood there for another moment, feeling the pulse, before we left. Outside, Dale checked my oxygen saturation. 97%. His was 98. Both normal. No headache, no nausea, no disorientation. Whatever the mine air contained, it wasn't acutely harmful. We sat on the tailings pile, and Dale told me what he thought. The smooth surfaces were real, and he couldn't explain them through any normal geological process acting on granodiorite within the time frame of the mine's existence. The pre-existing natural void hypothesis was the most plausible, but it had problems. The smoothing extended into the mine tunnel itself, covering surfaces that were clearly human excavated. That meant either the smoothing process was ongoing, actively working on the rough-cut rock and converting it to the smooth morphology, or the miners had somehow roughened previously smooth rock in only the first 40 feet of the tunnel, which made no sense. The breathing was consistent with Helmholtz resonance driven by barometric micro-changes, but the regularity was exceptional, more regular than any natural cave breathing system he was aware of. And the asymmetry of the airflow was genuinely puzzling. The transition line migration he couldn't explain. He agreed that moisture could affect the visibility of the boundary, but the rate and consistency were difficult to reconcile with any humidity-driven process. The water residue he'd send to a lab in Denver if I wanted. A basic water chemistry panel would tell us if there were unusual dissolved minerals or organic compounds. Then he asked me the question that I think he'd been holding since we crawled out. When was the last time you measured the smooth area in the tunnel? The first 40 feet where it starts on the ceiling. I told him I hadn't remeasured it. I'd noted where the smoothing began, about 2 feet past the concrete seal, and I'd observed that it covered the ceiling and upper walls. But I hadn't marked its lower boundary in the tunnel the way I'd marked the transition line in the chamber. You should, he said, because if the transition line in the chamber is moving upward, and the smooth surfaces predate the mine, and the process is ongoing, then the smooth area in the tunnel might be moving downward. I felt something shift in my chest when he said that. Not fear exactly, more like the sensation you get when you've been framing a wall, and you realize the foundation underneath it isn't level, that everything you've built is true to itself, but false to the ground it sits on. You're saying it's spreading, I said. I'm saying you should measure it. That's all I'm saying. I went back in alone the next morning, June 15th, and I measured. In the tunnel, the smooth section of the ceiling extended from about 2 feet past the seal to a point I marked at the 40-foot mark, where the tunnel entered the chamber. That was the full length of the tunnel ceiling. But the transition on the walls, the boundary between smooth upper surfaces and rough lower surfaces, was at 54 inches on the left wall and 51 inches on the right wall. I had not measured these values before. I had no baseline. I couldn't say whether the smoothing had moved downward since my first entry a week earlier. All I could do was mark the current boundary and measure again later. I placed chalk marks at the transition line on both walls at the 20-foot mark in the tunnel, protected them with duct tape, and noted the measurements in my clipboard log. Then I did something I'd been putting off. I examined the concrete seal from the inside. The interior face of the bulkhead was unremarkable rough concrete, same poor mix as the exterior, with the irregular surface you'd expect from a pour against natural rock. But at the top of the seal, where the concrete met the tunnel ceiling, there was a gap. Not an air gap, the concrete was in contact with the rock, but a color gap. The concrete was gray. The ceiling rock immediately above it was dark, much darker than the granodiorite elsewhere in the tunnel. Almost black. I touched it. The surface was smooth, the same smooth as the rest of the ceiling, but it had a different texture, slightly yielding. Not soft exactly, but with a faint give that the surrounding rock didn't have. And it was warm, not hot. Just noticeably warmer than the cold stone around it. Maybe 50 degrees, against the ambient 36 of the surrounding rock. The dark area was roughly 18 inches long, and maybe 4 inches wide, running along the joint between the concrete and the ceiling. I pressed harder. The surface depressed slightly, maybe a millimeter, and returned to its original contour when I removed my finger. I pressed it again and held my finger there. After about 3 seconds, I felt something I will describe as precisely as I can. Beneath my fingertip, under the surface of the dark material, something pulsed. A single, brief expansion and contraction that moved through the material like a ripple through a membrane. It wasn't synchronized with the air-breathing cycle. It was independent. A single event responding to sustained pressure. I removed my hand and stepped back. I stood in the tunnel, looking at the dark patch at the top of the seal. And I understood not intellectually, but in the way you understand that a floor is about to give way when you feel the joists flex, that I was not looking at rock. The dark area at the joint between the concrete and the ceiling was not geological. It was something that had grown into the gap where the seal met the stone. Something with substance, warmth, and a response to touch. I left the mine. I did not run. I walked at a normal pace through the tunnel, crouched through the entrance gap, and stood in the sun on the tailings pile. I called Dale that afternoon and described what I'd found. He was quiet for a long time. "Send me a photo," he said. I told him I hadn't taken one. I'd been rattled enough that I hadn't thought to use my phone. "Go back and take one." I didn't go back that day. I spent the rest of the afternoon replacing the tarp over the entrance gap and driving to Buena Vista for groceries and a new headlamp because the batteries in mine were getting weak. Normal things. I wanted to do normal things for a few hours. That night, from the porch, I could hear the breathing, not feel it, hear it. The low, rhythmic exhalation from 60 yards downhill. It was louder than it had been the first night. Whether that was because the gap was larger now, or because the amplitude of the breathing had increased, or because I was simply more attuned to the sound, I couldn't say. The following morning, I went back in with my phone. I took photographs of the dark patch at the seal joint, the smooth tunnel ceiling, the chamber, the transition line marks, and the entrance to the descending passage. The flash on my phone produced stark, flat images that looked nothing like what I'd experienced. The smooth surfaces appeared as uniform gray planes, without the flowing contours visible in person. The dark patch photographed as an indistinct dark smear. I could see that the photos would prove nothing to anyone who hadn't been inside. I did not touch the dark patch again. I measured it. 19 inches long, 4¼ inches wide. When I'd found it the day before, I'd estimated 18 inches long and 4 inches wide. I hadn't measured precisely then, so the difference could be measurement error, or it could be growth. I went back to the transition line marks in the tunnel. 18 hours since I'd placed them. Left wall, 54 inches, unchanged. Right wall, 51 inches, unchanged. I checked the chamber. The transition line had moved upward another inch since my last measurement, 2 days earlier. It was now at approximately 71 to 72 inches around the perimeter. In the 8 days since my first measurement in the chamber, the transition had risen roughly 10 inches. I collected all my data, crawled out, and sat at the cabin table with everything spread in front of me. I had temperature readings, airflow velocities, cycle times, transition measurements, physical descriptions, and a set of mediocre photographs. I had Dale's observations. I had the property records and the patent documentation. I had the absent closure record. I had the dark patch. Here is what I believe I found, stated as conservatively as I can. The Marguerite lode mine, driven into a granodiorite hillside in the 1890s, at some point intersected a pre-existing natural void characterized by smooth, organically contoured rock surfaces. The smoothing process, whatever it is, appears to be ongoing, slowly converting the rough, human-cut surfaces of the mine tunnel to match the morphology of the natural void. The system exhibits a highly regular breathing cycle driven by an unidentified mechanism at depth, connected to a water-filled passage that extends to an unknown distance below the mine level. There is a biological or quasi-biological material present at the junction of the concrete seal and the tunnel ceiling that responds to touch and exhibits possible growth over short observation periods. Lyle Kreider worked this mine for decades. At some point, he sealed it with private, undocumented concrete work and sold the property without explanation. My grandfather lived 50 yards from it for 30 years and never looked inside. My grandmother kept the property for another 20 years. Nobody told anyone. Nobody filed anything. I reported the erosion damage to DRMS on June 20th. I described the undermined seal, the absence of a closure record, and the water intrusion. I did not describe the smooth surfaces, the breathing, the transition line, or the dark patch. The intake specialist said someone would be assigned to evaluate the site, but she couldn't give me a timeline. She suggested I avoid entering the mine for safety reasons. I told her I understood. I drove back to Salida on June 22nd. I had a kitchen remodel waiting and a crew that needed direction. Normal work. I went back to doing the things I know how to do. Dale's water samples came back from the lab in Denver 3 weeks later. The basic chemistry was unremarkable. Low dissolved solids, near neutral pH, no heavy metals above background levels. But the organic chemistry panel flagged something the lab tech described in an email as an unidentified high molecular weight compound, possibly biological in origin, present at very low concentration. She asked if the sample had been collected from a thermal feature. Dale told her no. She didn't follow up. I have been back to the cabin twice since June. Both times I checked the transition marks in the tunnel and the chamber. In July, the tunnel marks had moved. Left wall, 54 inches down to 52 inches. Right wall, 51 inches down to 49 inches. The smoothing had advanced 2 inches downward in roughly 5 weeks. In the chamber, the transition line was no longer measurable. It had reached the ceiling. The entire chamber's ceiling, walls, floor was uniformly smooth. The dark patch at the seal joint had expanded. It now covered an area roughly 24 inches long and 6 inches wide. The concrete around its edges was discolored and slightly soft, as if something were slowly dissolving the calcium compounds in the mix. The breathing continues. Same rhythm, same cycle time, same temperature gradient. I timed it in July and got an average of 6.47 seconds across 20 cycles, virtually identical to June. I haven't sealed the entrance. I bought the materials quick-set concrete, rebar, form lumber, and they're sitting in the back of my truck. I've driven to the cabin twice, intending to close it up. And both times I've sat on the tailings pile and listened to the breathing and driven home without mixing a single bag. Here's what I can't resolve. Kreider sealed this mine. He used private concrete without notifying any agency. And then he sold the property. I've been thinking about that decision for months. He didn't just walk away. He sealed it first. He made a deliberate choice to close it. And whatever his reasons were, the seal held for 60 years until the spring runoff undermined it. I opened it. Not on purpose, but the effect is the same. The mine is open now, and whatever process is occurring inside the smoothing, the breathing, the dark material at the seal is exposed to surface conditions for the first time in 6 decades. The transition measurement suggests the smoothing is directional. It's moving outward from the deeper portions of the system toward the entrance. In the chamber, it has reached completion. In the tunnel, it's advancing. At the seal, something is dissolving the barrier between the inside and the outside. I'm a contractor. I understand what happens when you breach a containment you don't fully understand. You assess the risk, you stabilize the situation, and you call in someone with the right expertise. I've done the first two. The third one is where I'm stuck, because the expertise this requires doesn't correspond to any specialty I can name. It's not mining engineering. It's not geology. It's not biology. It's not hydrology. It's some of each and none of them completely. I keep coming back to the breathing. 6.5 seconds per cycle. The same in June as in July. The same whether I'm inside or outside. The same whether the entrance is tarped or open. Whatever drives it, it's been doing it long enough to reach a stable equilibrium, probably much longer than the 60 years the mine was sealed. The miners broke into it in the 1890s. Kreider worked the mine for decades and apparently coexisted with it until something changed his mind. My grandfather sat on the porch above it every summer for 30 years. The breathing isn't new. It's not something I caused by opening the seal. It was there the whole time, behind the concrete, in the dark, pulsing with the same 6.5 second rhythm it probably held before any of us were born. What might be new, what I might have caused, is the direction of the smoothing. I have no baseline from before the seal was breached. I don't know if the outward progression was happening behind the concrete for 60 years, or if it started when I opened the gap and changed the thermal and humidity conditions inside the system. I don't know if I accelerated something that was already inevitable, or if I set something in motion that Kreider's concrete had been successfully holding in place. The materials are in my truck. I can reseal it. I can mix the concrete, set the rebar, pour a proper bulkhead with modern materials and technique. It would hold longer than Kreider's. Decades longer, probably. But I keep thinking about the dark patch at the top of the old seal. That material grew into the gap between concrete and rock. It found the joint, and it filled it, slowly, over years, over decades. If I pour new concrete, and the smoothing continues to advance, and the dark material continues to grow, then someday, whether I'm alive to see it or not, it will find the new joint too. Kreider knew that. I think that's why he sold the property. Not because the seal failed, but because he understood that the seal was temporary. That it was always going to be temporary. And that the only thing he could do was give himself and the next owner enough time to not have to think about what was behind it. I've given it a lot of thought. And I know what I should do. I should reseal the entrance, report the full scope of what I found to DRMS and the Colorado Geological Survey, and let qualified people make the next decision. What I don't know, what I genuinely cannot determine, is whether Kreider's approach was wrong. Whether 60 years of silence and concrete was a failure, or whether it was the most honest response available to a man who found something that doesn't fit inside any framework designed to manage it. The breathing hasn't changed. I checked last week. 6.48 seconds, average of 15 cycles. The air still pulses through the gap I made, cold and mineral sweet, as regular as anything I've ever measured. I'm going back up before the snow flies. I'll either pour the concrete or I won't. I've made the decision both ways at least a dozen times. Every time I decide to seal it, I think about the dark patch finding the new joint. Every time I decide to leave it open, I think about Kreider, who looked at the same evidence and chose concrete. There's one more thing. The last time I was at the cabin, late July, I walked the slope below the mine entrance, the same survey I'd done in June, looking for springs or seeps that might indicate where the mine drainage was exiting. In June, I found nothing. In July, about 200 yards downhill and slightly west, near the tree line where the spruce begins. I found a patch of ground where the grass was different. Thicker, greener, roughly circular, maybe 8 feet in diameter. The soil at the center of the patch, when I pushed my boot into it, was warm. I didn't dig. I didn't measure. I stood there in the late July sun, on a mountainside my grandmother loved for 50 years, and I looked at the warm ground at my feet. And I thought about what might be under it. And I walked back to the cabin. Some things you inherit. The cabin, the claim, the sealed mine, the breathing in the dark. And some inheritances come with a question that the person who left them to you chose not to answer, not because they didn't know, but because they understood that knowing and answering are different things. And that sometimes the most responsible thing you can do with a question is pass it along intact. I'm still deciding what to do with mine.